Okay, hi guys. This is the first lesson for Unit 2. So we've finished Unit 7. We're going to go on to Unit 2 now, which is all about trigonometry. Okay, and trigonometry deals with triangles. Okay, and Lesson 1 specifically is about tan. So for this unit, you're going to need a scientific calculator because you're going to have to be using these three buttons here, the sine, the cos, and the tan buttons. If you don't have a scientific calculator and you have a smartphone, usually your smartphone, if you just rotate it to the side, if you flip your phone sideways, you can access the scientific calculator, okay? But you do need to find these three buttons here on your phone or your calculator. So we can use trigonometry to solve for missing sides and missing angles in a triangle, okay? So a triangle, of course, you have three sides and three angles, okay? So we're going to use trigonometry in this unit to solve for something that's missing. For this unit specifically, we will always be working with right triangles, okay? And a right triangle is a triangle that contains a 90-degree angle. So every single triangle that we work with in this unit, you're going to see the little square like that, and that indicates that this right here is a 90-degree angle, and that makes this a right triangle, okay? Today we're going to be talking about tan specifically, or tangent, same thing. Okay, so today we're going to be using this tan button right here. So the tangent property, this is kind of a law in math, okay? First, actually, before I explain that, I'm just going to walk us through a triangle here and how we label a triangle. So of course a triangle has the three vertices here, okay, the three corners, if you will. And I've labeled these three corners A, B, and C. And we always label the corners with capital letters, okay? So A, capital B, capital C. The sides we label with the same letters. So the side that's opposite A will be little a. The side that's opposite B will be little b. And the side that's opposite the big C will be little c. Okay, and that's how we label the angles with capital letters and the sides with small letters. Okay, so this is the tangent property, the law. If angle A is an acute angle, okay, so here's angle A, all right. And if it's an acute angle means less than 90 degrees. Okay, so less than 90 degrees would be this size right here. If we drew a line like that, that is a 90-degree angle. So we can see it is quite a bit less than 90 degrees. Okay, so if angle A is an acute triangle or an acute angle in a triangle, then the tan of angle A is equal to the opposite side to angle A divided by the adjacent side to angle A. Okay, so what that means is if you're trying to look for angle A, if I said find the size of this angle, is it 30 degrees, 40 degrees, 50 degrees? What is it? To find the size of this angle, we can use this fraction right here. And the fraction is the number on top is the opposite side to angle A. So the opposite side is the one way across, okay? So the little a. I'll write that. And it's divided by the adjacent side to angle A. Okay, adjacent is a fancy word of saying the one beside it. So here's angle A, but here's the problem. I actually have two sides beside angle A. This side that's really close to angle A is side C, and this side that's really close to angle A is B. But this side right here, you might remember from grade 9, this side right here, because it's opposite the 90-degree angle, every side opposite the 90-degree angle is called the hypotenuse. Okay? So this side's called the hypotenuse, this side's called opposite. So this is the adjacent side. Okay, so just to recap that again, if I'm talking about angle A here, this is where I'm starting from. This is the opposite side, the one way across. The hypotenuse is the one opposite the 90-degree angle. And so then that leaves this one to be the adjacent side. Okay, so in this case, the adjacent side to angle A, we labeled as this one, C. Okay, and so creating this little fraction here will help us find whatever angle A is. So determine the ratios for tan of angle D and tan of angle F. So when I say determine the ratios, that's a fancy way of saying the fraction. Okay, so I give you actual numbers here, and I want you to create the fraction. So the first one I want you to do is set up the fraction for the tan of angle D. So here's angle D. I'm looking from this angle. This is like my eyeball. I say I'm looking from this angle. Here is our right angle right there. So if I know that the tan is the opposite side divided by the adjacent side, I have to start right here and figure out which side is my opposite side. Well, the opposite side is the one all the way across, okay? So the 3, okay? Then I have to say, well, which one is the adjacent side to my angle? Now, adjacent means beside, so it's either this one or this one. But we know that this one's the hypotenuse because it's the one opposite the right angle. So that leaves this one to be adjacent. And there you go. That's how you would label the tan of angle D. I want to also do it for the tan of angle F. So now we're switching and now we're looking from this angle, F. So if I'm looking from angle F and I want to create the ratio of tan for angle F, I start by looking at what's the opposite side to angle F. The opposite side to angle F is the one all the way across the triangle, so 4. And then from angle F, I want to look for the adjacent side. So adjacent means the one beside it. I have 2 lines beside it, but I know that one's the hypotenuse, so I go with the other one, which is 3. So you can see how the fractions change depending on what letter or what eyeball you're looking from. Okay. Another question like that, determine the ratios for tan of X and tan of Z. So same type of question. Here's your right angle. I want to start with tan of X, tan of angle X, sorry. So I'm starting with tan of X. This is like my eyeball. We always know that it's the opposite side divided by the adjacent side. So looking from X, which side is opposite? It's the one all the way across the triangle. So 6. Divided by the adjacent side, well, this one's the hypotenuse because it's the one opposite the right angle. So then the adjacent side is the other guy, 12. And you should always get in the habit of reducing your fractions. So it's actually 1/2. Let's repeat with tan of angle Z. Okay, so now Z is my eyeball. I'm looking from here now. So I want the opposite. It always is opposite over adjacent. So the opposite side is the one all the way across the triangle. So 12 divided by the adjacent side. So that's the hypotenuse. It's not going to be that one. It's the other one adjacent. So 12 over 6 reduces to 2. Okay, so there's just a few questions to practice how to create your fractions. And now we're actually going to solve. Okay, so here it says determine the size. So I actually want to know how many degrees is it? Is it 20 degrees, 30 degrees, 40 degrees? Okay, so we're actually going to use our calculators here. So you have to get your calculator out or have your phone ready. So here it says determine the size of angle G and J. So we'll start with G. Okay, so to figure out the size of G, I go tan of angle G and I create my fraction. So I know it's always opposite over adjacent. So here's my right angle, sorry. So if I'm looking from G, the opposite side, the one all the way across the triangle is 4. And the adjacent side is the 5 because this is the hypotenuse, right? We don't want to use that one. Okay, so now here's what you do to figure out the actual size. If you look at tan right here, you'll see right above it is tan minus 1. Okay, we have to access that button, the tan minus 1. So whenever you're looking for an angle, you have to use the -1 button. To get to that, I have to press shift on my calculator. It might be second on your calculator or inverse on your calculator. But if I go shift and then the tan button, I see tan -1 pop up. And then I'm going to open the bracket and I want that of 4 divided by 5. Okay, so that's what I did. Shift tan of 4 over 5 equals 38.659, etc., etc. So that's the size of my angle. And it says here to round to 1 decimal place. So that 5 is going to round the 6 up. So it's actually 38.7 degrees. Okay, let's do another one because I also wanted to find J. So let's try tan of angle J. So now this is my eyeball. So it's opposite over adjacent. So opposite on top, adjacent on the bottom. So the side opposite to J is all the way across, so 5. And then adjacent to J is the 4. So now I do the exact same process. I go shift, tan, open up my bracket, and I want 5 divided by 4 in my bracket. And I get 51.3. Okay, so you might have to do some fiddling around with your calculator. Some calculators make you type in the fraction first and then go equal and then go shift tan. That works on my calculator as well. Okay, so this calculator is awesome because you can go in either direction. Some calculators are older or your phone might only let you do it in a specific order. So just fiddle around with it for a little bit, but make sure you're pressing the shift or second button so you're accessing that little -1. Okay, all right, last question. What is the size of the indicated angle rounded to the nearest degree? So I've indicated the angle here. So I just haven't put letters in. Okay, so you're allowed to choose any letters you want if there's no letters in. So I like ABC. Okay, this is my right angle right here. So we know that this 5 is the hypotenuse because it's opposite the right angle. And I am looking for B. So I'm going to write tan of angle B equals, and I always know it's opposite divided by adjacent for tan. So this is my eyeball. So from tan B, I'm looking for the opposite side all the way across the triangle, which is 3. Now the adjacent side means, adjacent means beside. So is it the 4 or the 5? They're both beside angle B. I'm going to go with the 4 because the 5 is the hypotenuse. It's special. So we kind of leave out the hypotenuse. So I want tan of 3 over 4. So I go shift tan, open up the bracket of 3 divided by 4, and that gives me 36.869. It's actually very close to this one up here, not quite though. But it says I want it rounded to the nearest degree. That means no decimals. So 36.8 is closer to 37. So I'm rounding it up to 37 degrees. Okay, and that's how you use the tan button on your calculator to find missing angles in a triangle. And in the next couple of lessons, we'll do sine and cos, the other two.